Welcome back to my channel. Today, we're diving into an urgent and complex topic in global health, a highly virulent, antibiotic-resistant superstrain of bacteria rapidly spreading across Asia. Known as SD164, this strain of carbapenem-resistant Acinetobacter baumannii, CRAB, presents a significant public health risk due to its resilience against antibiotics and limited available treatments, which has made it a high priority for global health organizations. This SD164 strain of CRAB, recently identified in a Chinese intensive care unit (ICU), as part of a study aimed at evaluating infection prevention, is notable for its extreme resistance to carbapenem antibiotics. Carbapenem is a critical drug class used for treating severe bacterial infections that are resistant to other antibiotics, making the SD164 strain especially concerning. Over a 3-month period in 2021, researchers from the University of Birmingham and Zhejiang University in Hangzhou conducted a genomics surveillance project in this ICU. They discovered that a staggering 80.9% of A. baumannii cases were CRAB, with the SD164 strain making up 40.2% of these instances. This finding highlights the strain's rapid emergence and its established foothold in hospital settings, posing a real risk to critically ill patients who are already vulnerable to infections. The current research builds upon a previous 2019 study conducted by the same team in Hangzhou, where nearly one-third of ICU patients were infected with CRAB. During that earlier study, a different strain, GC2, was found to be dominant, constituting 99.5% of cases. However, by 2021, this figure had dropped significantly to 50.8% as the SD164 strain rapidly took its place. Since mid-2020, the SD164 strain has been evolving, developing nearly double the resistance levels to carbapenems as the GC2 strain. Researchers fear that SD164 may be establishing itself in hospitals throughout Asia and potentially beyond, emphasizing the urgent need for rigorous infection prevention and control (IPC) measures. One of the study's co-authors, Professor Alan McNally from the University of Birmingham, highlighted the unique characteristics of the SD164 strain, stressing that even though it caused fewer infections than GC2 during the study period, its heightened antibiotic resistance makes it a pressing concern. The SD164 strain's resistance level is alarmingly high, and it has already shown itself to be highly adaptable within ICU environments. Patients infected with CRAB can develop severe diseases like pneumonia, urinary tract infections, bacteremia, meningitis, and soft tissue infections, making it crucial for hospitals to adopt stringent measures to control its spread. Due to the strain's capacity to persist on surfaces, medical equipment, and within hospital infrastructure, CRAB infections can spread within 48 hours of a patient's admission, facilitated by factors like shared medical devices, airflow, and even plumbing systems. Containing outbreaks of CRAB can demand extensive interventions, including infrastructure changes, which add significant logistical and financial strain on healthcare facilities. One of the key tools in this battle against CRAB and similar superbugs is genomic surveillance, which was used in this study to map and analyze the spread of the SD164 strain. The researchers utilized high-resolution whole genome sequencing and comparative analysis, a powerful approach that helps to track how the strain evolves and spreads within hospital environments. This genomic approach allows scientists to identify critical shifts in the bacterial population and respond proactively to mitigate the strain's impact. Professor Willem van Schaik, also from the University of Birmingham, commented on the global public health implications of CRAB, particularly the SD164 strain, which not only threatens patient health but also places an immense burden on healthcare systems around the world. Given the limited treatment options available, he emphasized the urgent need for new therapeutic agents, as well as continued IPC strategies, to reduce the morbidity and mortality associated with CRAB infections. The World Health Organization, WHO, has even designated CRAB as a priority pathogen, underscoring the urgent need for novel therapeutics due to its global prevalence and the devastating consequences of untreated infections. In summary, this study not only raises awareness of the challenges posed by antibiotic-resistant infections but also underscores the importance of continued research, funding, and global cooperation to combat superbugs like CRAB. The Medical Research Council and the National Natural Science Foundation of China provided support for this research, recognizing the need to address the emergence of drug-resistant bacteria in hospitals and beyond. This research shows how genomic surveillance and strict IPC practices will be crucial tools in managing the threat posed by antibiotic-resistant superstrains. The spread of CRAB, particularly SD164, is a wake-up call for healthcare systems worldwide to remain vigilant and innovative in the fight against antibiotic resistance. Thank you for joining me on this in-depth look at an urgent issue in public health. Be sure to subscribe for more updates on important health topics, and let's keep the conversation going in the comments. What are your thoughts on antibiotic resistance and its implications? Stay safe, and I'll see you in the next video.